we were talking about, you had said that you were having a hard time with the if statements concerning the gas mileage questions.
Correct.
Okay. Again, as I said, I just started re-recording, so we flipped over to the class time. So again, recap, and then we'll kind of cover that. At the top here of my screen, you're going to see starting on line 10. That section is basically the stuff we're going to cover here in a few minutes. And it's the same exact formula questions that we had from last week. If you guys remember, that's where we ended. But to kind of cover the if statements for the problem, if I remember correctly, this is the gas mileage problem. F1S, mileage, millage, spelling, M-I-L-A-D. That's fine, whatever. There's no spelling contest here. So I believe, if I remember correctly, we have a 200-mile limit that we're interested in. So let's talk about the variables, or actually, Stephen, do you remember the variables that are required to kind of do this calculation?
Well, we have a percentage, mileage, and capacity.
I just got a notification. If there are a bunch of people who are not muted, if you can mute yourselves so that way it'll kind of eliminate any audio problems we may be having. Never seen this before, but just check to make sure you're muted. The percentage in tank is one of the variables. What were the other ones, if you could please?
Well, let's see. What you have the percentage of tank. You have the gauge.
Gauge?
Correct.
Define that for me.
Gauge.
Are you talking about the gas gauge?
Correct. Gas gauge and I
well,
guess.
That is the percentage of tank. The gas gauge
correct.
represents how much, right. So that really is the same thing, right? So
percentage of tank.
Really, that represents the gas gauge. Well, we
right.
have a size of the tank, right?
Yeah, size of the tank. And possible mileage.
Is this the desired mileage we want to travel?
No, the desired mileage that whether you get like 23 miles per gallon.
Okay,
miles
so
per gallon, that was it.
Okay. All right, and then we need one other. Okay, so that then we need a target distance, right? And we've got to know how far we can travel.
And that's where the 200 miles comes in.
Right. Okay. So, but we're going to set it, but it's still just a kind of a variable that we can use, which is the target distance. And the reason that I want to emphasize you guys putting these kind of variables in there, even when they're hard coded, because later on, you can, if all of a sudden you decide that you need to change that problem to 500, it requires that amount of effort. It doesn't require you to go through the code and figure out what is where and whether it's a 200 because it's a distance or if it's a 200 because it's some other factor you've added in. Okay. So let me ask you, let's walk through this logically. If I told you that your car has enough gas to travel 140 miles, would it be able to get the distance? Would it be able to cover the travel distance? No.
Logically, right? Yes.
Well, right. I mean, it's only got 140 miles worth of gas in there. So logically, you know that to be the case. So the first question then is, if you know that relationship, you figure you got one piece, which is target distance, right? So this is here on line 27. This is one piece.
Well, I see now. I mean, as far as the distance and mileage, the target distance, I didn't put that in as a variable. I wasn't even using that.
You
I
can
was
use
trying
just
to
the
work
straight
around
200.
it.
You can just use the straight
I
200.
wasn't. Didn't even list that as a variable.
Well,
I was trying to list that as an if statement.
You can do it that way. There's nothing wrong with that.
No. Okay.
The reason I put the variable in here is so that way it's kind of a best practice. It's kind of a better way to do it because, again, when we write code, we want to write it so that way we can reuse it later. We want to write it so that way we do it once and then we keep it and we just have it around just in case. So we don't have to keep reinventing the wheel. We invent the wheel once. We got all the work done on it. We set it up so it's easy for us to use, and then we just use them when we need them. So let's talk about we talked about a little bit of the logic behind this, right? We kind of get the idea that if you got to calculate how much gas you have and how far your car will travel on that gas, and then you compare that to how far you need to go, right? Steven? Did I lose you? Hello?
No, you didn't lose me. I just muted myself so I wouldn't create an issue.
Oh, okay.
With background noise.
Oh, yeah, I'm here. Thank you very much. All right, so, again, let's just kind of walk through the process of how do we calculate how much gas we have in the tank in number of gallons. Well, we say it's going to be the size of the tank, right? The size of the tank, and then we're going to multiply that by the percentage of the tank that we have, right? That's a pretty easy calculation. And for simplicity's sake, we can just make a variable to handle that, right? So we could just make a variable called gallons of gas and just calculate that out. Well, if we know how much gas we have, we know how many miles per gallon we get, we can then figure out how far we can travel, right? We can figure that out by saying, gallons of gas times miles per gallon, right? Everybody following along with this? With some yeses. Oh, and hey, Matt, sorry I didn't see you. All right, good. So we can store this piece of information too, so that way it's real easy for us to be able to deal with it, right? So we can say this is effective distance to travel. Or I guess effective travel distance. Effective travel distance. That's going to be equal to this. So now we know how much gas we have and how far that will take us. So now, really what we need to do is now we need to make a comparison between how much distance we have in our car as it stands right now and our total target distance, how far we want to go. Okay? So you guys, does everyone here know how to write an if statement that'll do that? If your target distance is going to be less than or equal to the effective travel distance, well then we can just console log out the thing we want, right? And I forget what it is it asks you to console log out. I mean, at this point, though, the logic, you guys should get the logic. So else, we're going to console log out. Okay, let me make sure that's right because you got to always double check these kind of conditionals. So the target distance, if the target distance is less than the effective travel distance, in other words, you have more gas than you have to travel, then you will be able to get there. That looks right. So then we would just basically run it just like this. All right, does anyone have any questions about the kind of the logical process I went through to get to this?
Mm.
And of course, I've written my semicolons. Let's keep doing this on the fly. Perfect. That's what I want to hear. All right. Okay, so I'm going to use this now as kind of a bridge to kind of talk to you guys about the idea of taking bits of code and encapsulating them so that way they can be reused over and over and over again. Because really, what do we really have here? We really have kind of a little, we divide it right here. We have some calculations, okay, that have to go in, and then we have some outputs down here at the bottom. But in reality, this is all kind of something that we could reuse over and over again, right? I would like some yeses and nos for this, because this is going to lend itself heavily to what we're going to do here in a minute. Well, I got one yes, and I'm going to have to be satisfied with that. So I'm going to set some just basic values in here for the time being. So we're just going to do 100, 100. I don't know. Again, some random values just to kind of act as placeholders. Okay. Imagine that what we would want to do is we want to create ourselves a little calculator that's going to let us know, just by plugging in some information, whether or not we can cover a required amount of distance. Or maybe how about this? We will want to have it simply calculate out the portion that is how much effective distance we have to travel. So right now we have this section right here that is a little bit of calculations that we want to kind of clean up and make encapsulated so we can reuse it over and over again. So let's kind of write down what we're going to do here. So we would like to encapsulate the okay, so we're going to encapsulate the effective distance code for our vehicle. So we're going to take that little portion, that little calculation, and make it into something that can be reused. So in order to do that, we're going to create what's called a function. And the function is basically going to take in some inputs, it's going to perform some actions, and then it's going to spit out a single output. That's what functions do. Functions always take in one or more, or from zero to many inputs. They perform some actions, and then they push out some, they may or may not push out some data directly. So I know that sounds like a whole lot of ifs, but you'll get it kind of when we kind of get into it. So the way we write a function, again, it's a code encapsulation. We start with the word function, and then we're going to need to name it something. So in this case, we're going to call it distance calculator. All right. So then we're going to put some parentheses in here and some curly braces. The parentheses are where we put in parameters. What is a parameter, you ask? I know you're waiting for this one. A parameter is basically a variable that goes in and is used inside of the function. So I want you guys to keep in mind here, this function that we have down here is what's, well, in C it's called a prototype. Basically what that means is it's the declaration of the function. The variables that you use down here in this function declaration are not going to have to be the same variables that you use when you use the function. Does anyone understand what I'm talking about? You can turn on your microphones. Excellent. Okay. So the idea, Stephen, the idea is if I create a generic operator, or basically if I take, I think a real world example, something we used over and over again. Have you ever worked with, I guess a jig isn't a good example. Let me just show you what it looks like in reality, and we'll try to pull something together from there. So our distance calculator takes some information as we see up here, right? So up here we have some pieces of information it takes in. So it takes in the size of the tank, okay? It takes in the percentage of the tank, and then it also takes in the miles per gallon. So those are the three things it uses to calculate the effective travel distance. Do you follow that, everybody? Okay, so we're going to create three variables inside of this function that are going to do that. So we're going to create one called tank size. We're going to create one called MPG, and we're going to create one called percentage tank. If you notice, these names are different than the names of the thing above. You'll understand, I'll explain again, kind of making that more clear in a minute, but I want you just to, again, I want to draw that to be very, very clear. Okay, so when we write a function, this section up here is where we're passing in parameters. These are basically going to be pieces of information we're going to pass into the function to be used within the scope of the function. So how do we calculate things within the function? We're basically going to take the information that we're getting in and perform the required calculations. When we want to push something out, we use the return. So return basically says, whatever we have in here after the return, send that out and replace the function when it's called with that information. So in this case, I would like to just to start with produce a very simplified version of what's going to happen, which is we take the size of the tank, the percentage of the tank, and multiply that, all of those together, and multiply that by the miles per gallon, right? So basically it's the product of those three factors. So we can do that here. We can do tank size, comma, times MPG times, comma, times percentage tank. Okay, so what is this really doing now? All this is doing is saying, hey, I am going to pull in some information and I'm going to do some calculations. That's all it's doing. And it's going to return the product of those three values. It's very simple. So I'm going to now use this function, and we'll see how that works here in a second. So in order to get the information out of the function, I actually have to call it. And the way that I call it is, in this case, as a console log. So we're going to do a distance calculator, and the first thing we need to do is put in the size of the tank. I'm going to use hard-coded values here, so I draw this parallel. Let's say we're going to do 20 gallons is the tank size, miles per gallon is 10, and the percentage of the tank is 1/2. Okay? Now, I'm going to comment out these other sections of code here. That section right there, I'm going to comment out. We'll get back to that in a little while. And then we're just going to run this. Okay. So let's look at what shows up. We have a console log that says you will get there, which makes sense because here on this if statement, see what happens there? That is the code that we originally wrote, this if statement. And then down here we created this function, and then we called that function with this other piece of information. So at this stage, all this stuff we have right here, we're going to comment out just to eliminate, but we'll pull it back in here in a moment. So we're going to rerun it just to validate. Now we're down to 100. Let's see if that makes sense. 20 times 10 times 1/2, yeah, that's about 100. Should be 100, so that makes sense. Well, let's say we want to reuse it. So we're going to reuse the distance calculator, but this time we're going to use the variables that we have up here on line 25. So we have, or 25 to 28. So we're going to take the size of tank variable, which is currently equal to 100. Size of the tank. Then we're going to take this variable, what's next to miles per gallon. We'll take the miles per gallon variable that we have up top. And then we're going to take, lastly, the percentage of the tank. Okay. If you notice, and we're going to run this. Okay. And that makes sense. The math, that kind of makes sense, right? It's 100, it's that, and then, so we have a full tank. It takes, as 100 gallons. They get 12 miles per gallon, so it should be, right, 12,000 miles. Because the percentage of tank should be 1. Right, 1,200, right. Okay, so can everyone here see that we've reused the code written from 43 to 47 multiple times to perform calculations with different values? And did you notice, pay very close attention here, this right here, the tank size, matches what you see on line 43, not what you see up here on 26. The difference there is critical. This idea here of taking and writing these functions so that way they perform these actions, this section is different than what's out here and what's down here. And that's very, very, very important for you guys to understand. So we now have a small function that performs some action that can perform basically a distance calculator for us. But what would happen now if we also wanted to, if we remember previously here on line 37, I'm going to uncomment that for a moment, we had this, what we had coming out here was we had a comparison, and in the comparison, we ended up with these strings that we would actually console log out. Well, what I would like to do is to create another function that would perform those actions for us, so that way we could basically kind of compress everything and make a call, a function call that would then return the strings that we're interested in. So again, in order to do that, we would, let's comment these guys out again. And add a new function. And this is effective. And is that the name of anything else? Doesn't look like it. The parentheses, the curly braces. Okay. So we have this function that we're interested in making, and let's quickly make a comment as to what it is that it's going to do. It's going to return a string. of whether or not a set distance can be traveled. Okay. In order to perform, if we look back up here again to this, we have two things that we're interested in. So we have an effective distance and a target distance. So those are the two pieces of information that we're going to pass in. So in this, we're going to call this a target and effective travel distance. So we can write a quick if statement. We're going to create a variable real quick to hold the string we're going to pass back out. So I want to show you guys the syntax for this because this is a common practice. So we're going to create a variable called return string, and we're going to set this just equal to an empty string for the time being. Then what we're going to do is now we're going to create our if statement that's going to use our target and ETD variables. Okay, so we're going to do an if statement. So if the target is less than, the target is going to be less than or equal to the effective travel distance, or ETD as I'm calling it, then we're going to set our return string is going to be set equal to you can make it, else return string is going to be set equal to you can't make it. Then, once that comparison is made, we're simply going to return URN, our return string, RETURN. Okay? There we go. Okay, so does everyone follow what happens here? Again, I need some firm affirmations. Okay, so now for the fun part. So, we have the distance calculator function returns what? It returns the effective number of miles that you can travel, right? Which in the case of our effective distance function is actually the same thing as our effective target distance, right? Again, I'd like an affirmation of that, please. Which those two things are equivalent. So if they're equivalent, can't we comment this out real fast? Can't we do something like this? We have the effective distance. The target is going to be equal to the target distance variable that we have at the top. And then we said we have a distance calculator variable, function, I'm sorry, and it takes in the tank size, which we can call the size of the tank, then the miles per gallon, and then the percentage of the tank, all right, does everyone see what's happening here? Good, that's what I want to see. So now let's run it so you can make it. So now I'm going to tear it apart and just validate that everything here makes sense. Actually, we've already seen it. It's 1,200 miles, so we know it's going to make sense. So again, this idea is that this function returns an effective value that is a numeric value, which is then applied to the other function that's being called. Again, you can nest these functions in any required order to produce this effect. And the key here is to begin this idea of tearing things down into these little tiny pieces and then running them as you need them. So just for a moment, let's talk about this idea of passing around and where to slice up functions in order to kind of fulfill your best practices. A lot of people have a tendency to want to throw console logs in here, right? But here's the problem. It's great to do it if you're debugging a function, but if you're depending on a function to write to the DOM, to write to something outside of its own scope, that's really kind of not a best way to do things. It's much, much better to return the values out of the functions, out of this scope, which is this section, return those values. It will work only inside the functions. I'm not sure what you mean. The console log will work every time. If you put it inside of a function, it will work every. It will work every time the function is called. And if, as a best practice, it makes more sense to not use things like that to try to manipulate your objects, but instead to compartmentalize them in such a way that you kind of use them outside of that scope. And again, I'm not saying that's going to be 100% true. I'm simply saying that do not, when you're starting out, don't lean on that as your primary way to institute functions. It makes a lot more sense, especially at this stage, to pull and get your return values out in a logical structure, so that way you can then handle them at a higher level within the scope, or outside of the scope of a function, but instead in kind of the main scope. Does everyone follow along with that notion? Good. Who am I missing? Real quick, I just want to check. No, it is only 3 of us. Nice. Okay. Or I guess 4. Sorry. I keep forgetting myself. All right. So, that being the case, do you guys have any questions about this idea of functions? I'm going to do one more. I'm going to do this temperature one that we had from before. Real quick, I'm just going to do a quick commit on this. Where are you at? Come on, GitHub. Oh, what did I call that? There's class canvas. Okay. New. Oh, so I'll just call it week 4. Week 4. Yeah, sorry for my lackadaisicalness in that. Okay. So I'm again going to take this section and kind of comment it out. And I'm going to go back up here, comment this section out. And then we're going to start and just pull this section down. All right. So since the last time we spoke, I couldn't remember what the variables were, and I looked them up, or what the calculations were. So these are corrected calculations from last class. And so we're simply going to take this and kind of compartmentalize it so that way we get what it is we're looking for into a function. Okay. So our function is still going to take in two parameters. And this is converter, so temp. Okay, so we're going to have a temp function ourselves. We're going to have a temp converter
And I want to
function
point out
that we're going to create.
And
inside of that, we're going to. Somebody just joined?
There's the book, Tough Topics.
Did someone just join?
I find that absolutely fascinating, so check it out. It's right there on our website. 1-877-548-3675.
Hello?
Well done. All those questions, and you touched on all of them, so thank you for that. Okay, lots of great questions online. Scott, you're in Minnesota. Thanks for joining us. Your turn now, please.
Yeah,
Hello?
I just have a question.
Hello? Yeah, I have, let's see if we can figure out what is the audio controls for this.
Hello, can you hear me?
Yeah, yes, who just joined?
This is Richard Mapano.
Are you looking for a classroom?
A go-to meeting?
Yes, for a school?
Yes.
Okay. All right, can you mute it?
I'm sorry?
Can you mute your mic?
Okay.
All right, so if everyone here is joined, so what we have here is all we're taking is we're going to have this temperature convert function, and from that we're just going to pass in the two variables that we have over here above, right? So we have these two variables, the temperature and then the C or F variable, and we're going to perform the same operation we did before, and so it's going to be a, let's just do CF as our CORF variable, and then the temp, we're just going to use T, and we will simply clean up below to mirror that. Now, I'm not a big fan of using single variables as my naming convention, but in this case, it will do. So all I did was basically take this code and kind of encapsulate it with some curly braces, change the variables so that they all match what I have up here on line 62. And then from there, now we're just simply going to call it. So how do we call a function we've created? We call it by name, and then we pass in the variables that we're interested in and the temperature. Okay, and so what will happen here is when we run this, it will ask us if it'll run this prompt, it'll run the second prompt, so at 59 and then at 60, and then finally it will perform the calculation and log the answers out. Now again, as I said before, best practice is not to do this, so let's clean this up real fast. So we're simply going to turn this into a return. I assume everyone is following along with this. Good. Okay, so as you notice, I'm performing the calculations and returning without the use of an additional variable. This is a completely viable option. It's just another way to perform the action. And then, so now we don't have a console log to pull this data out. So if that's the case, we need to put one in. We're going to console log the values. And there we go. Now we're going to use this again, but in a slightly different way. Okay, and we're going to simply take the prompts that we had from before, and we're going to reuse them here. So I want you guys to see that this is also a viable alternative. Now, again, this is not clean, and so I wouldn't really do it. But again, if there's a push comes to shove moment, just keep in mind that the prompt value returns the information, and so then you simply perform the calculations. Everyone follow along with that idea? Excellent. Okay. So that's basically it for functions. The only other idea we need to cover today is this notion of loops. So let's talk a few minutes about loops. Okay, what is a loop? A loop is simply a process that is performed over and over and over again. It's basically a structure that allows us to do that in such a way that it makes things easy. So we can, simply count up the number of times something needs to happen and perform those actions, or we can, after the fact, or basically perform a series of actions as long as the condition is not met, or until a condition is met. So remember how we talked about the idea of ifs, where you will, is something true or is something not true? Loops can work in exactly the same way. So they're basically, generally we're talking about kind of three types of loops, but really they're kind of only two. So there's for loops, and then there's while loops. And then there's also something called a do while. I don't use them very often, but we'll talk about those here in a moment. So for loops are just kind of if we know how many times we need to do something, or we can calculate how many times we need to do something, a for loop is the perfect tool. Now, we talked about arrays, haven't we? I didn't see any yet. I couldn't tell us. Yes, good. Okay. So we talked about arrays. Everyone here should be very familiar with this syntax. Let's call this. Okay, we're all familiar with that syntax. So what the for loop looks like, and actually I'm just going to add a few things in here. So we're going to do VANA. I don't know. There we go. So again, we have an array here. It's just got some basic information inside of it. So there are currently 4 values in there. So if we remember, we can do this. And the test array dot length. Again, we'll just run that real quick. There are 4 values. So we know that, right? We can calculate that. So when we talk about for loops, it's very easy to talk about arrays. The syntax for a for loop, just so you know, is you're going to have a variable that controls the for loop. And I guess that's really that the for loop controls. So the variable I typically use is I, and that's just because I've been programming forever, and that was kind of a convention when I started. So in this case, I is our control variable. We have to set it equal to something. We can set it equal to any number we want, but just for clarity's sake, it's usually easy to simply start with 0 and count whole numbers. So then what we do is then we're going to set up a condition. So the first thing is we set, the first part here is we set the initial value, and then we're going to set the second part is we're going to set the condition for how long the thing is going to run. So as long as I is less than 10, then we have a third piece, and that is we're going to do something to I. In this case, we're going to do I++, which is equivalent to I equals I plus 1. Those two things are equivalent. And then we're going to put some curly braces. Curly braces are where things happen. So we can do, so we're going to do a console.log the value of I. Okay, so what's going to happen here is now we should have the length of the array come up, and then we should have this I value come up. So let's look and see what happens. Oh, look. So we have first the value of 4, which would be what we expected, and then look, all the different values of I. So it started with I equal to 0, and then it went 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to change things around a little bit. So if we start I at 3, let's run it. And now look, it goes from number 4, which we expected again from the length of our array, and then 3, 4, 5, 6, 7, 8, 9. So does everyone follow along exactly with what is happening here? Yes, excellent. So let's do this. We're going to change it one more thing here. We're going to go back to 0, and we're going to now do I is going to be less than or equal to 10. Less than or equal to 10. If we notice now 10 is included where previously 10 was not included. Again, there's a slight difference. We can do this also. So now we're adding 2. So let's see what happens. It goes, again, we start our 4 from our length, and so now we go 0, 2, 4, 6, 8, 10. So we have half as many numbers, everything there. Again, it's simply adding to I. So if that's the case, this number 10 is a finite number. So in the cases of arrays, well, we know that the size of an array is dependent only on how many elements we have within that array, right? So as we push in new items, those items are then appended at the end of the array. So we can take our test array length we were talking about before, and we could put it there and return our syntax this way. And now, if we console log test array, and we place the I value in there, let's see what happens. Can anyone guess? Is that what you expected? We have banana, pear, peach, right? And then, but oh, look, we have an undefined. Well, that's because it's less than or equal to. We want to set that equal. We don't want to include that last number because it's really a fifth item, and so there we are. So let's say previously we had 4 items, right? So now let's say we want to add a new item into this. So we can do test array, and we're going to dot push. I think it's push. Well, test array. It's push. Let's see. I believe this is syntaxically correct. Yes, so does everyone here see what happened? Yes, now you see the value, right? Now you see what's going on. So now, if we needed to console log or walk through all of the possible combinations that or all the possible items, so again, if we added another item, now it's simply added another item, and our code still works because everything here is being logged out, and the length of the array, which is constantly changing, goes, in this case on line 84, it goes from 4, or it entered in as 4, and then on 86 it goes to 5, and then on 87 it goes to 6. So then each of these values are then pushed out. Fairly simple and clean, nice as can be. So what I'm going to do real quick is we're going to write a loop within a loop, because I want you guys to understand and kind of follow along this idea, because it's kind of important to understand this notion. Okay, so now if we're going to put a loop within a loop, we don't use the same variable that we used in the first loop because it's going to impact the second, right? Yes. So we're going to create a second variable. We're going to call that j. And then the third variable, if we wanted to do a loop within a loop within a loop, we might call it k or l or m and n and so forth. Now, there's overhead associated with that, meaning there's a processing requirement, but that's neither here nor there. So at this stage, we may have we may want to simply count to 10. So j less than 10. We're going to j plus plus. Okay, and now we're going to put some curly braces in here, just like we had on the outer loop. And let's simply console.log out the value of j. So what is it now? Do you all expect to have a specific value coming out? Does it look like this? It starts, the length is calculated, we put out the banana, then we put out all these numbers, then we put out the pear, then we put out all these numbers, then we put out the peach, then we put out all those numbers. Make sense to everybody? Yes. All right. So now we're going to do one last more loop within a loop within a loop. So, and I'm going to impress upon you guys this is why this is kind of cool. Okay, so for k is going to equal 0, we're going to do k is going to be less than 3, and we're going to do k plus plus. Okay. Now I'm going to clean this up and shorten this a little bit because I want you guys to see the basics of what's going on here. So I'm simply shortening up this section here for this test length and removing that, and instead I'm just going to put in a set value again. So we're going to put in 3 will be fine. Okay, and 3. Okay, so now we're going to console log out some values, and so what we want to do is we just want to include each of our values at each point. So then we have j. All right, so let's just real quick go look at this and see what it looks like when we run it. Okay, so what's happened here? I want you guys to conceptualize what's going on here with this loop. So the innermost loop fires, and each one of these counts from 0 to 1 to 2. Then that happens. Then the middle loop fires and increments. It, at the same time, the k then increments a bunch of times. Then the j increments again, and the k increments a bunch of times. Then the I increments, and then j increments, and k increments a bunch of times. Again, you'll see this pattern start to emerge. And it's important that you get this idea, get this concept into your heads. All right. So that part I'm going to leave up there. I'm going to throw another quick for loop in here just for the sake of, giggles. I is going to be less than test array dot length plus plus, and then just going to throw this back in here. Test array, we call it, and that should run. Okay, so the last piece we need to talk about is this idea of the while. So a while loop basically is do this until something is until something becomes false, basically. I guess until a condition is met. So something becomes true or something becomes false. So while I is let's see. Actually, let me put it this way. We create a variable called do a while condition. Okay. Equal false. So, as long as while condition equals false, then you're going to do some stuff. Once the while condition becomes true, it'll stop doing it. So let's see, we may do a prompt. Is this still true? Or is this, how about this is not true? Let's see, this is test. So let's say we want to do something like if the while test is not true. I guess, hold on, it doesn't want me to use that. Sorry, wrong syntax. Sorry, I'm switching languages. Then we can make the while condition equal true. Okay, so what's going on here? So we create a variable, and that variable we're setting equal to false. We're testing that variable to check to see if it is false. As long as it is false, we're going to continue to ask the person if for this value. If that value is not equal to true, then we're going to, as long as they keep saying true, we're going to keep asking them. As soon as they say false, then we're going to, or anything else, then we're going to stop asking them. Does everyone follow along with the logic of that?
Yes.
Good. Okay, so I'm going to leave this up here, and I'm going to talk very, very quickly about this idea of a do while. A do while is exactly like a while statement with one caveat, and that is that the do happens no matter what. This while condition, if I started this like this, if I started like that, this while would never fire. It'd never ask, because it's automatically going to be false, right? A do will always happen no matter what. All right. So all right, so then this could be again, the same thing, prompt. I'm not sure the syntax for this will work, but I'll clean it up here in a second. Again, I'm trying to rush here so I can hit the deadline. Z equals. Okay. So again, let me just clean this up a little bit. So again, syntax-wise, this isn't a particularly hard concept. I mean, it looks pretty similar to other things we've done. But logically, there's just this subtle difference that makes a huge impact on what's going on. Because the do always will run once, even if Joe, you know how to spell. Even if this, okay, we create a variable called z, and we make that false. So it is not ever true. It then prompts the user, and then unless the user changes the value to true, it will not happen. It'll fail out after that. But the point is simply that it will run at least once, period. No matter what happens, it will run once. And again, when you're programming, those little subtle differences make huge impacts. All right. Yes?
So basically the do while is how I'm comprehending it is the variable, you assign the variable variable z as false, and then your do while is saying if if z is false, prompt the user to ask if it's true, and if it's true,
Nope.
No.
Nope. So I think you missed the first portion, the while portion. So what the do while is a variation on the while loop. So what happens is no matter what z is, no matter what it is, it will always it will always perform whatever actions are between the curly braces following the do. So this section that's highlighted there, went from 20 to 28, it will always do that. And then, once it's done it once, it will check to see if it still should run it again. But it will not do that check until it has run it once. The while condition is not the same thing.
Okay.
Okay, so do you guys have any questions about this? All right. Excellent. Perfect. All right. Well, if you guys have no questions, then I have nothing else for y'all. So I think we've covered the raw material. If you guys have any questions, don't hesitate to write me an email, and I will try to get back to you ASAP. You guys are excused. Hey, thank you very much. This has been a lot of fun, as always. And get those projects done quick, man. The faster you get started, the easier it'll be.